Okay, so today we're going to start Unit 5, and Unit 5 pretty much covers Chapter 10. You have vocab posted and a Unit 5 schedule. The vocab we do the last day of this unit. Otherwise, there are homework assignments every day, and it'll just be a regular unit. This unit, we're going to start with Lewis structures. And Lewis structures are representations of atoms or molecules. This is not really what they look like, but it's meant to represent the atom or molecule, and it's meant to show where the electrons are and where the bonds are. Those are models. They're not going to include everything in the models, but Lewis structures are a little more specific. Okay, so a Lewis structure for an atom is a Lewis dot diagram. And you've seen these before. These have one dot per valence electron. And we don't pair them until we have to pair them. So an atom in group 1, like lithium, has one valence electron, and it gets one dot. It doesn't matter what side the dot goes on, as long as there's just one. An element in group 2, like magnesium, with two valence electrons, needs two dots, and we don't pair them, but it doesn't matter if they're right and left or top and bottom. They're probably going to be on opposite sides because of electron repulsion, but right and left, top and bottom doesn't matter. Transition metals we just leave out for now. You could do it if you were told how many valence electrons, but we don't usually cover that. Group 13 with 3 has 3 dots. Group 14 has 4, 1 on each side. 15 has 5, so one side gets a pair. It doesn't matter what side. 16, 6, opposite sides get 2, the other opposite sides get 1. 17 with 7. And then the noble gases with 8. So those are Lewis dot diagrams for elements. And it's just one dot per valence electron. And you don't pair them until you have to pair them. Those are really the rules. Questions about Lewis dot diagrams? Okay. The next thing is a Lewis structure. And a Lewis structure has some rules or steps to drawing them. But what it is a representation of the bonds and unpaired electrons in a molecule. Step 1 to drawing a Lewis structure is to add up the total valence electrons. Step 2, pick a central atom. which is always going to be the least electronegative. And never hydrogen. So, where's the most electronegative? Do you remember?
At least or
Most.
Yeah.
Fluorine, top right, is the most electronegative. So your central atom in your Lewis structure is going to be the one that's farthest away from fluorine of all your options. So you make that in this, you put that in the center. Then, number 3, bond atoms, all other atoms, to your central atom. Step 4, fill in excess electrons as lone pairs to fill octets. We'll talk about what all this means in a second. Double or triple bond as necessary. And I'll explain what that means in a second. Okay, so you have a molecule, any molecule, let's say water. And you're supposed to draw a Lewis structure for water. Step 1 is to add up the total valence electrons. Each hydrogen, 2 of them, has 1 valence electron. And my oxygen has 6. So I have 8 total. Step 2, pick a central atom. Which one goes in the middle, oxygen or hydrogen? Oxygen, never hydrogen. So oxygen goes in the middle. And then I bond the other atoms to the central atom. Each bond represents 2 electrons. Maybe add that. 2 electrons per bond. This is a covalent bond. So oxygen and hydrogen are sharing 2 electrons here. That's what covalent bonds are, is the sharing of electrons. So if each bond is 2, I've just used 4. I have 4 left. I am required to use all 4 electrons. I have to use all my electrons. And I need to use them to fill any octets, any atoms that do not have a full outer energy level. Hydrogen only needs 2 electrons to fill its outer energy level. And both of my hydrogens have 2. So I don't need to worry about those. How many does oxygen have right now? 4. 2, 4. How many does it need to fill its octet? Oct. What's oct? 8. All atoms need 8 electrons besides hydrogen and helium. So it needs 8. It has 4. So these 4 are going to go on here as lone pairs. I've used 2, 4, 6, 8. I've used them all. And all of my atoms have complete octets. So I'm done. That is the Lewis structure for water. We're going to find out later this week that it's actually not quite that, but we'll find out why later. Questions so far? Does this make sense? Okay, let's do another example. Carbon dioxide. Add up total valence electrons. Carbon has 4. There are 2 oxygens with 6 each. So I have 16 to work with. I need to pick a central atom. Carbon or oxygen? Carbon is farther from fluorine, so it goes in the middle. I've just taken up 4 of my 16. I have 12 left. At this point, I start filling in lone pairs, and you always want to start on your outer atoms. So 12, 2, 4, 6. Each lone pair is 2 electrons. 8, 10, 12. I've run out of electrons. I don't have any left. Do I have all of my octets full? No. Carbon only has 4 electrons. Don't write this. Can I just do this? No, I don't have electrons to fill in. I don't have extras. That won't work. This is where double and triple bonding comes into play. At this point, I can take one of my lone pairs from each of my oxygens and move it into a double bond. The only time you have to double and triple bond is if you've run out of electrons and you have not filled all the octets. Then you're going to need to move electrons into double bonds or triple bonds. Now, oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. I've used 2, 4, 6, 8, 10, 12, 14, 16. So that's my Lewis structure. It's kind of like a puzzle. Sometimes you finish and you're wrong and you have to fix it. Okay, let's do one more. The only other exception to the rule is for ions, like sulfate. So I add up electrons. Sulfur has 6, 4 oxygens with 6. This 2 minus, what does that mean in terms of electrons? There's 2 extra. A minus charge means you have 2 extra. If it was a 2 plus, I would subtract 2. It's a 2 minus, you add 2. Add it up. 6 times 4 is 24, plus 6 is 30, 32. Pick the central atom, sulfur or oxygen. Sulfur is farther from fluorine, just slightly. Bond, 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 bond. I have 24 left. 4 outer oxygens. We'll get 6 each. I've used all 32. They all have 8. So I'm done. The only other tiny little thing is if it's an ion, you have to put it in brackets and put a 2 minus charge up in the top right corner if I had room. Okay, that's it. Your day 1 assignment is page 285, 1 to 8. Work on that, and that's it.